Good morning, class. So, by the way, I'm Jan Abituna, your student teacher for today. So, today we'll be talking about the zeroth law of thermodynamics. So, what is the law of thermodynamics? So, today, um, you, my students, will be um, able to state the zeroth law of thermodynamics and illustrate and explain the zeroth law of thermodynamics, and lastly, explain the practical application of thermodynamics. So, thermodynamics, the zeroth law of thermodynamics states that if two systems are each in thermal equilibrium with a third, they are also in thermal equilibrium with each other. So, this statement implies that thermal equilibrium is an equivalence relation on the set of thermodynamics system under considerations. So systems are said to be an equilibrium if the small random exchanges between them so do not lead to need a change in energy. This law is tacitly assumed in every measurement of temperature. Thus, if one seeks to decide whether two bodies are at the same temperature, it's not necessary to bring them into contact and measure any changes of their observable properties in time. The law provides an empirical definition of temperature and justification for the construction of practical thermometers. So the zeroth law was not initially recognized as a separate law of thermodynamics, as its basis in thermodynamical equilibrium was implied in the other laws. The second and third law has been explicitly stated, already found common acceptance in physics community before the importance of the zeroth law for the definition of temperature was realized. So, as it was impractical to renumber the other laws, it was named the zeroth law of thermodynamics. Okay, so it states that the thermodynamic system are each in thermal equilibrium with a third one, so they are in a thermal equilibrium with each other. So, by the way, we'll be having our topic review. So, no heat flows between the objects in thermal equilibrium when in thermal contact does not mean a physical contact. So that is what we call a zeroth law of thermodynamics. So an amount of heat requires to raise 1 gram of a substance by 1 degree Celsius. That is, yes, right, specific heat. It is work and heat that describes the path taken to get from one state to another. Yes, process, function. Gas A is in thermal equilibrium with gases B and C. What is a valid conclusion from this? Gases B and C are in thermal equilibrium with each other. So, the zeroth law of thermodynamics deals about temperature. Do not exchange energy or matter with their surroundings. Total change in internal energy is zero. That's what we call a isolated system. The transfer of thermal energy from a hotter object with higher temperature to a colder object with a lower temperature. That is correct. Heat. The zeroth law of thermodynamics provides and blank. So, empirical definition of temperature and the classification for the construction of practical thermometers. Okay, so that's the end of our discussion. So, prepare your science activity notebook and then your ball pen, for we will be having the the formative assessment. So, an actual agent is to be designed having the same efficiency as the Carnot cycle. Such a proposition of the proposition is, okay, it is possible but with a lot of sophistications. Okay. So answer the following statement correctly. So write your activity notebook. Just write the date today and indicate your name and your section, and then number your paper from 1 to 10, and then you can you only given 10 seconds to answer each question. So please listen carefully. Number 1. No heat flows between objects in thermal equilibrium when in thermal contact and does not mean a physical contact. Number 2. Amount of heat required to raise 1 gram of substance by 1 degree Celsius. Number 3. It is a work and heat that describe the path taken to get from one state to another. Number 4. Gas A is in thermal equilibrium with gases B and C. What is the valid conclusion? So, number 5. Zeroth law of thermodynamics deals about. Number 6. Do not exchange energy or matter with their surroundings. So it is a total change in the internal energy is 0. Number 7. The transfer of thermal energy from a hotter object with a higher temperature to a colder object with a lower temperature. Number 8 and 9. The zeroth law of thermodynamics provide an blank and blank. Number 10. An actual engine is to be designed having same efficiency as the Carnot cycle. Such a proposition is. Time's up. So let us check your answers. Okay, number 1. No heat flows between objects in thermal equilibrium when in thermal contact and does not mean a physical contact. What is your answer? Yes, correct. Zeroth law of thermodynamics. Then number 2. An amount of heat required to raise 1 gram of substance by 1 degree Celsius. Okay. Your answer is specific heat. Yes, correct. Number 3. It is a work and heat to describe the path taken to get from a state to another. What is your answer? The answer is the process function. Number 4. Gas A is in a thermal equilibrium with gases B and C. What is the valid conclusion? So that is B and C is in a thermal state of equilibrium. Number 5. Zeroth law of thermodynamics deals about temperature. Yes, correct. Do not exchange energy. And number 6. Do not exchange energy or matter with their surroundings. So total change in internal energy is 0. That is isolated system. So, next. The zeroth law of thermodynamics provides an empirical definition of temperature and the classification for the construction of practical thermometers. Okay, so that's all for today, and I hope that we met our learning objectives. So, thank you for watching and listening. And bye-bye.